How many solutions does cos to the nx plus cos to the 2nx equals 0 have in the range 0 less than or equal to x less than or equal to 2 pi for an integer n greater than or equal to 1? And we're given a bunch of options for depending on n. So what are my thoughts here? First thing that comes to mind is to solve for cos x in terms of, treat this like a quadratic equation and solve for cos to the n of x. So if I write this as cos to the nx plus cos 2nx is equal to 0, let's let y be equal to cosine to the n of x. So then I have y plus y squared equals 0. This is the same as y times y plus 1 is equal to 0. So this says that y is equal to 0 or y is equal to negative 1. So then this says that cosine to the n of x is equal to 0 or cosine to the n of x is equal to negative 1. And now let's just figure out, this has two roots, right? Cosine to the power of n, cosine n x equals 0. This says that is the same as cosine x equals 0. That has two roots in the range we're asked about for x between 0 and 2 pi. If you just visualize what the cosine function looks like, standard sinusoid shifted, it crosses from top to bottom and then once more from bottom to top. So that's where the two roots there come from. And here, this has no roots if n is even, and one root if n is odd. So if n is even, this of course never holds, right? Because the left-hand side will always be non-negative. But if n is odd, then this becomes the same as cosine x equals negative 1. And again, if you visualize what the cosine function looks like, there's only one value of x between 0 and 2. In fact, x will have to be equal to pi, right? X equals pi solves this when n is odd, but nothing solves it when n is even. So we have for even values of n, we have two roots, and for odd values of n, we have 3. So I hope that's one of these solutions. Yeah, it is. That's option D. So I'm pretty confident in this one. There were other things that crossed my mind when looking at this, like maybe using some trig identities to simplify these expressions or something like that. But I don't know. I just thought that this might be a better, this treatment and just solving for cos to the power of n of x might have been a more likely first step to actually yield a useful result, and it certainly did. But yeah, maybe you play around with, replace this with, this is the same as cos squared x to the power of n, and maybe there's something you can do there, but yeah, I think that's likely to turn into a little bit of a mess. So this was ended up being a pretty straightforward way of solving the question. Thanks for watching.